Hey mathematicians, Caitlin Henderson here with another lesson video. This is the Unit 7 Lesson 3 video, and we are talking about area in the coordinate plane. The last lesson, we've talked about the perimeter, we've solved for distance. Now let's apply it to area. So first and foremost, we're going to work with rectangles. To find the area of a rectangle, we take the length and we multiply it times the width. Now, it doesn't matter which one's the length and which one's the width. It's just important to note that we want to find the length of one side of our rectangle and the length of the other side of our rectangle, and then multiply them together. So if we look here, you can see that our scale here, right, is jumping by 2. So we're starting at 2, and then we're going to 4, and we're going to 6. So we can solve for the distance, remember, in a couple of ways. We can skip count, so we can say 2, 4, so our distance is 4. Or we can take our ending distance, which is 6, and subtract it from our starting place, which is 2. And that tells us 6 minus 2 is 4. But what we're going to call here as the length of our rectangle is going to be 4. Now for the width, once again, we can skip count. So we're starting at 2 here, and we're ending at 4. And we can skip count by saying 2, right? We're jumping by 2. Or we can take our ending point, 4, and subtract it from our starting point, 2. 4 minus 2 is 2. Okay, so we have our length and we have our width. Now we just plug it into our formula. Area is equal to length times width. We're going to say that our length is equal to 4 and our width is equal to 2. And that means 4 times 2 is 8. So our area is going to be 8 units squared. I'm saying units squared because we don't know what the exact measurement is. But do remember that we're working here in squares. Okay, so this is how we would find the area of specifically a rectangle that has its sides on a vertical or a horizontal line. You can see it, you can count it super easily. Now, what happens if we're on a diagonal? If we are on a diagonal, we are going to need to use the distance formula. And remember that and I didn't say this before, I'll say this now, rectangles have opposite sides that are congruent. So if you noticed, I only found the length of one side, where in theory, right, and like when we're working with triangles, we're going to have to find the length of all 3 sides. But because our rectangles here, opposite sides are congruent, we just need to find one side. So for this example here, we need to find the length of 2 sides in total, okay? We can call this one our AB side, and then we can call this one our AD side, okay? These are going to be the sides that we're going to find, and then we don't need to find the other sides, once again, because we're only working with length times width, and the opposite sides are the same. So anyways, let's get started by finding the length of our AB side. Now remember, when we're using the distance formula, we need to know our starting points, okay? So I'm going to have this be x1 and y1, okay? And I'm going to have B be x2 and y2. Okay, and A is located at x is 2. We go down to our x-axis, x is 2, and y is 4. And then for our B point here, we go down to our x-axis, and we are at x is 4, and y is 6 here. Okay, so these are the locations of our points. Now we can plug them into our distance formula. Remember, our distance formula is equal to x squared minus our x2, our second x point, minus our first x point, which is x1, and our y2 minus our y1, also squared. And I'm going to extend this all the way over. Okay. Our first step is always to replace the values. So x2 here is equal to 4, and we're subtracting x1. See, x2 is equal to 4, x1 is equal to 2. And then we are going to take y2, which is equal to 6, and subtract it from y1, which is equal to 4. And we still have the squared and the plus sign. We haven't done anything with that. PEMDAS, order of operations, please excuse my dear Aunt Sally, tells us what order we solve for equations like this. The first thing we have to do is solve for the inside of our parentheses. Okay, so we're going to do the subtraction in each one of these parentheses. So 4 minus 2 is 2. And 6 minus 4 is 2. Okay, so we have 2 squared and 2 squared. And then, once we've solved for inside our parentheses, we can take care of the next step, which is our exponents. So anywhere we see an exponent, we want to take care of that. We have 2 squared, which is the same thing as 2 times 2, which is 4. And then we have the same thing again, 2 squared, or 2 times 2, which is 4. And now we have just an addition problem on the inside, which is fabulous. We get square root of 8. Now remember, it's always good to leave it like this for now. And then when we go to multiply it, we can multiply the exact values so that we can work with rounded at that point. So for right now, we are going to leave this as square root of 8. Okay, now that we've done the length of AB, let's do the length of AD so we can solve for the area. Once again, we're starting with our distance formula, and our first step is always to plug the values in. We have, in this case, let's make this our 0.1 and we'll make this our 0.2 just because it's already labeled. Remember, it doesn't fully matter which one, just it kind of depends, or the points that you choose could make it so that you have more or less negative numbers, but that doesn't affect the answer. So let's look and see, where do we cross our x-axis? We're touching the x-axis, so that means we're looking at our point being at x is 6, and because we're on our x-axis, that means y is equal to 0. Okay, so these are going to be our 0.2 points. So we're going to start by plugging them in. We're starting with x2, which is 6, and subtracting it from x1, which is 2. And then we are looking at y2, which is 0, and subtracting y1, which is 4. PEMDAS tells me that the first thing I need to take care of is parentheses here. So I'm going to look on the inside of the parentheses and solve for that math problem. 6 minus 2 is 4 squared, well 4, and then we have to square it. And then 0 minus 4 is negative 4 squared. And don't forget, you can plug this into a calculator if you're not sure. Don't always double check your work. Okay, up next, we are going to take care of the squares. So we're going to go 4 squared, which is going to be 4 times 4, which is 16. And then remember, when we're dealing with a negative, we can just forget about the negative when we're squaring, okay? And we could just do 4 times 4, which again is 16. Our last thing to do inside our square root here is 16 plus 16, which is 32. So that means that the length of this side is the square root of 32. Okay. Our next step is going to be finding the area. Remember, when we're finding area, we always want to start with our formula here, which is length times width. We can pick one to be the length, and we can pick one to be the width. And you are going to get out your handy dandy calculator, and you are going to plug in the square root of 32 times the square root of 8. And you are going to get 16. Now remember, if you were to put in the rounded answer for the square root of 32 and the square root of 8, you're going to get a decimal out because it's rounded, it's not perfect. But this is the benefit of putting in the square roots as their square roots, because you are going to get your answer as a whole value. Well, not always a whole value, but you have the chance of having it be more exact, I should say. Okay, so we found the area of a rectangle that lies on the horizontal and vertical lines. We've found the area of a rectangle that's on diagonals. Now let's look at the area of a triangle. Now, the area of the triangle, the formula is very similar to that of the area of a rectangle. And that's because a rectangle is basically 2 times the area of a triangle. So we can cut rectangles perfectly in half and form triangles. So what our equation looks like is half of the area of a rectangle. That's basically what it is. So we find the height and the length, or the length and the width kind of, and then we divide it in 2. Now we call, instead of using length and width, we call it base and height. And what that means is the base is going to be like our flat side that we are working with, the kind of the connection of 2 vertices. And then the height is going to be the distance that goes from kind of that point down to the base. We also call this height the amplitude, so you'll hear it called both ways. Now, this triangle that we're going to be working with today isn't upright like this triangle, okay? And for this triangle, if we wanted to find the base, we would just skip count. We have 1, 2, and then we have 1, 2 as our base and our height, okay? But this one isn't quite as nice. And basically, this is a triangle that you can kind of think of it being on its side. We don't want to find the height of the triangle this way and use this as a base. We also don't want to use this one as a base because they're diagonals. They're going to be super hard to find. So when we're looking for a base, we want to look for a horizontal or a vertical line, just like what is right here. This is going to become my base. Now, the height is the distance between the tallest vertex here and our base. Okay, this upper vertex here and our base. This forms a 90-degree angle. This creates our height. Now, because we're working with horizontal and vertical lines here, we can skip count to identify what the length is or subtract our starting and ending point. So here we have 1, 2, 3, 4, and our height is 1, 2, 3. Okay, so we found our base. This is our base, and this is going to be our height. And we're going to plug it into our formula. Area equals 1/2 base. And remember, we're multiplying here. This is a multiplication of the base and the height. And I'm going to replace my base value, and I'm going to swap them to parentheses. Parentheses just make it so that we know that the values are separate from each other and it stays really clean. So I'm going to write 1/2 base times the height. Whoop, height is 3, not h. We're replacing. There we go, 3. Okay, so this is saying 1/2 times 4 times 3. Now, I always like to do my whole numbers first, because if I'm working with an odd number, then I'm working with decimals, and mistakes can happen with decimals. So I like to do my whole numbers first, which is 4 times 3, which is 12. And then in my calculator, I can do 1/2 of 12, or 12 divided by 2. This is the same thing as 12 divided by 2. And that means if we do 12 divided by 2, our answer is going to be 6 units squared. So that is the area of this triangle here. Okay, we have a couple examples of different types of triangles that might throw you off when you're trying to calculate your area. Now this one here, look, it's an obtuse triangle. It's got a horizontal base, which is great, but look at this weird point that's shooting out over our base. We can treat this exactly the same. What you can do is kind of draw a dotted line to extend our base over, And then draw a line down from that upper vertex down to our base. And this is actually still going to be our height. You know, that seems a little wonky, but if we were to create a rectangle around this, that's where the line of our rectangle would be if we were to create a rectangle around this. You see that? This is the rectangle that forms the perfect half of our triangle. So this is going to act as our height, but our base is only the solid line. We don't want this dotted line for our base. It's only the solid line, okay? So the base in here, we're skip counting 1, 2, 3. So this is 3 units. Remember, we can also do ending point, which is 5, and subtract it from 2. Okay, those are both great ways to solve. And then our height is 1, 2. Remember, we can do ending point, which is 3, ending point, and minus 1, which is our starting point. And this will also get you 2. Okay, so this is the base and our height of our triangle. And then we can plug it into our formula. Here, I'll put it all in parentheses this time. Okay, area is equal to 1/2 the base, which is 3, and the height, which is 2. We always do the whole numbers first because if we were to find half of 3, we'd be working with a odd or with a decimal, and sometimes those can get tricky. 3 times 2 is 6, and half of 6 is 3. So that means that the area of, not cubed, squared. There we go. The area of this triangle is 3 units squared. We're going to do another funky example. In this example, what if all of our side lengths are on diagonals? Okay, if all of our side lengths are on diagonals, what we're going to do is what is called circumscribe our triangle with a rectangle. Now, as I mentioned before, triangles are usually half of a rectangle. In this case, we are not guaranteed because this triangle is wonky. It's different, you know, it's not, it doesn't have like a perfectly vertical or horizontal or vertical line, right? We're not working with a perfectly horizontal or vertical line. So what we have to do is find the area of our rectangle that we've created, find the area of our triangles, and subtract. So let's do this step by step. If you were solving this yourself, step 1, if you just had this triangle, step 1 would be to draw a rectangle around the triangle. And what you're doing is basically creating 3 90-degree angles around the triangle. Okay, we want it to be a true rectangle, so our opposite sides should be parallel and they should be congruent. So they should be the same length and they should be parallel to each other. Now we've got 3 triangles that we're working with. I'm going to call this yellow, this one green, and this one red. The first thing we want to do, step 1, okay, find the area of the rectangle. Okay, this is going to be our first step. Find the area of the rectangle. I'm going to skip count. We've got 1, 2 as our height, and we've got 1, 2, 3, 4 as our length or width and length. Okay, remember that the area of a rectangle is length times width. We are going to say that the length is 2 and the width is 4. So that means the area of this triangle is going to be 8. Okay, that is step 1. Step 2 is going to take a little bit more work. Okay, a little bit more work. Step 2, you need to find the area of each one of these little triangles. Now, let's erase what I have so far because I need the measurements of each one of our triangles. Let's start with the yellow triangle. And actually, I'm just going to write Y. Okay, no, that could be confusing. Yellow. Okay, for our yellow triangle, we want to find the area. So we're going to be working with area equals 1/2 base times height. Okay. And we are going to have our base be this one here, and let's actually make our color that we're writing with kind of a little bit more yellow. It looks like a mustard yellow. So our base here is going to be 1, and our height here is going to be 2. So we're going to plug in our values. Area equals 1/2 our base, which is 1, and our height, which is 2. We're going to solve the whole numbers first. So we're going to multiply the whole numbers together first. 1 times 2 is 2, and half of 2 is equal to 1. So the area of this one here is 1 unit squared. Okay, that's our area for our yellow. Now let's do our red. So for our red, we want to find the base and the height. Let's have this one be our base. We've got 1, 2, 3, 4. And let's this one be our height, which is going to be 1. So for our red one, we're going to do, remember, area equals 1/2. Let's do parentheses like we should be here, base times height, so we don't get them all confused. 1/2 our base, which is 4, right here, and our height, which is 1. Remember, it doesn't matter which one's your base and your height. You could totally have this one be your base. We're going to multiply our 4 and our 1 together, which gets us 4. And then that means our area for this one is 1/2 of 4, which is 2. So we've got 2 units. Okay, our last one is our green triangle. Our green triangle, let's say this is our base, and this is our height. So we have 3, and we have 1. Now we're going to write out, I guess we should write green. And I'm going to be squeezing this in a little bit. Area equals 1/2 base times our height. Okay. And then we are going to replace the values of our base and our height with the b and the h. So we're going to have this be our base, which is 3. We'll have this one be the height, which is 1. We're going to do the multiplication of our whole numbers first. So we've got 3 times 1, which is 3, and then half of 3, which is 1.5. So that means our area here is 1.5 units squared. Oh, I didn't put the squared here on my red one. Squared. There we go. Okay. Step 1, find the area of our rectangle. Step 2, find the area of our 3 right triangles. Now what are we going to do? Our last step that we're going to do here is we are going to subtract. Okay, let's do a little, this is going to be where we are going to, where we're going to do our final answer. Okay, our last step, our step 3. Okay, step 3, we are going to take the area of our rectangle, which is 8, and we are going to subtract the area of each one of our triangles, 1, 2, and 1.5. Okay, so 8 minus 1 minus 2 minus 1.5. This is going to get us our area of our triangle right here. Okay, so what we're doing is we're taking the area of the whole thing, we're subtracting these 3 areas, and what's going to be left is my blue highlighted triangle that I put in right here. Okay, this is going to be the area that is going to be left once we do our subtraction. So in our handy dandy calculator, we're going to type in 8 minus 1 minus 2 minus 1.5. And we are going to get that the area of this triangle is equal to 3.5 units squared. Okay, 3.5 units squared. This is the area of our triangle when we are asked to circumscribe the triangle in a rectangle. And remember, we do this method when all of our sides are on a diagonal. And all of our sides are on a diagonal. All right. So before we end, I do want to note that there is another way. We talked about it in class. It's also taught in the book, and that is finding the area using a trapezoid. Review that. However, the 3 triangle method that we just did should work on most triangles. When it doesn't work, and let's go back here, when it doesn't work is if the triangle were to kind of extend. So let's say that, I don't know, It's a super obtuse triangle. Let's say, I don't know, this is our triangle. And it's a super obtuse triangle like this. Okay, and we have this kind of missing piece that's going to be right here. This is what you should look for. If you have this missing piece and you're doing the triangle method, just identify what the area is. In this case, it's a 1 by 1 square, so it's 1 unit squared. Identify what the area is, and then you are going to subtract that additionally from your answer. However, I don't believe you're tested on this, so just keep that in mind. Now, that is it for this lesson. If you have any questions, please reach out, and until next time, bye guys.